welcome back to my YouTube channel. So I'm back here with example number 9. So looking at this example, it looks like it's a very complicated example. But guys, believe me, once we start using the substitution method, it is going to become much simpler and we'll be able to actually evaluate the integral. But just looking at this, it seems like it's almost impossible to evaluate the integral for a function as complicated as this, because there's radicals going on downstairs, and then the functions, like there's a division, and like these are big functions as well, x to the power 6, and that upstairs is x to the power 5. So there's a lot going on here, but by using the method of substitution, we should be able to evaluate the integral of this function as well. So let us start with the steps, guys. Everything has exponents here, so we have to figure out like where we want to start. So again, you have to keep in mind, like you have to think ahead in terms of like, what if I start with this, what is going to be my next step? So thinking ahead, it seems reasonable to start with this as my substitution, because when I take the derivative of this expression, you know, I'm going to get exponent 1 less than this, so I'm going to get a 2 for here, and I'm going to get a 5 here. So that's what I have here and in my numerator. So that we want to start with something which has more higher powers than the other expression. So earlier also we chose things which have exponents, and in this case we want to choose something which has a higher power. Obviously both of them have higher powers than the numerator, so we're going to start with substituting starting with the denominator here. So the step number 1 will be to set u equals to the piece inside the radical. We don't want to include the radical. If we include the radical, it will become too complicated for us to find the derivative, guys. That is the other thing one has to keep in mind. We want to choose a function that you can easily find the derivative for. Okay, so it's going to be 2x cubed plus x to the power 6 minus 5. Once we start with that, then let us follow the step number 2. Take the derivative of this function du over dx. It's not too difficult. It's 3 times 2 is 6, x squared plus 6 comes in front, x to the power 5. We don't have to worry about negative 5 because the derivative of a constant is 0. So guys, we have something like this, but now we want to solve for dx. To solve for dx, again, you can think of an invisible 1. You cross multiply and you will get dx. So from here, I'm not like writing that step, but you can actually do that on your own. So dx will be du divided by let me write that here, 6x squared plus 6x to the power 5, right? Following step number 2, then step number 3 is just kind of bringing it all together and substituting values back in the original function. Guys, x squared plus x5, we'll keep it like that. We don't really have anything for that yet. And then downstairs, I'm going to have a radical of u. Okay, that's already going to make my life easier just by looking at just one variable here instead of this whole big expression. And then times dx, guys, dx will be replaced by du over, and guys, this guy, I can see that both have a 6 in common, so can I take out that 6? And if I take out that 6 as a greatest common factor, let's see what am I left with. I'm left with x squared plus x5. And that is good thing, because now I can easily cross these out. So I'm already like, I got rid of all the x's, everything is in terms of u and du, and that's what we want. And so it's going to look like this, du. Guys, when I cross these out, there's an 1 here. 1 times du is just simply du, and downstairs I have 6 radical u. Okay, you already know what to do with that 6 in the denominator. So it's like having 1 over 6. So we take that 1 over 6 outside, then it is simply that integral of du. Sorry, I don't want to write du first, so I'm going to write du here. And guys, this radical u in the denominator is same as like having u to the power 1/2 in the denominator, but we cannot really do anything with it as long as it is in the denominator. So what I'm going to do is I'm going to take it upstairs in the numerator, and when I do that, when I take it upstairs in the numerator, it's going to look like u to the power negative 1/2, right? Because it is u to the power 1/2 here. When I take it upstairs, it becomes the sign of the exponent changes from a positive to negative. You already know the basic rules for exponents. Now can we actually find write the integral of this? Yes, we can simply use the power rule to write the integral. 1/6 stays outside, and it's going to look like u to the power negative 1/2 plus 1, negative 1/2 plus 1. Guys, using the power rule, adding 1 to the exponent. So let us simplify this. It's going to be 1/6 u to the power 1/2, and this thing is divided by 1/2 as well. Now to get rid of this, when I get rid of this division, what happens? So it becomes like this: 1/6 u to the power 1/2, right? Times, when I change this division to a multiplication, I have to flip this, or I have to like reciprocate this. So this is going to be what, 2/1, right? I'm just reciprocating it, simplifying and reciprocating. If you like, you can put it in parentheses. Now we can simplify this further. It's going to be 2 and 6 is going to go away with 3. So it is, finally it is u to the power 1/2 over 3. Don't forget that c. So we're guys almost done, but we know that the original function is in terms of x, so our final answer should also be in terms of x as well. So I have space here to write that. U, what is my u? This is my u in terms of x. So guys, I'm going to replace this u by that. Guys, it's all about substituting, but you have to go back and like, I like to box them so that I can see those key substitution pieces. So here it's going to be 2x cubes plus x6 minus 5 raised to the power 1/2, or I can even put it in the as a radical if you like. It's up to you guys. If you put it as 1/2, that is totally fine. This whole thing has to be divided by 3, and then of course there's a plus c. Guys, I'm sorry I got like this not enough space here, but I hope you can see the last step as well. From here it's all about substituting back this u for 2x cubed plus x6 minus 5, and then there's divided by 3. Of course you have to put a plus c. Again, you want to verify this, is find the derivative of this, and you should get back this function. So guys, this was a little extra work, but still we're still following step 1, step 2, step 3. Okay, and then guys, you will, I mean, as you start working on this, you will it will come easy to you. Okay, so start working on these substitution examples. So look at these examples, understand the steps, understand the processes, then open your textbooks and start working on some of these examples on your own, and that's how you're going to actually get better at this. Okay, so this is example 9. I'm going to show you one more example on using the method of substitution, and then we're going to go into something some other methods as well. Okay, so guys, till then, take care. I will see you in the next video.